This is our second session for your security course, cybersecurity and digital forensics 4361601. So let's continue with uh, the unit that we already discussed last week. Today, we are supposed to consider these topics so that we are able to complete unit number 1, introduction of cybersecurity and cryptography. So let me just do a recap. We actually looked at basic concepts of information security. We also looked at the confidentiality, integrity, and availability triad. We're also looking at OSI security architecture. So let me just brief you through the OSI security, right? You are already aware about these topics. However, we need to take them with reference to how we look at uh, security in terms of various attacks. So you're already aware with reference to computer networking that the content between two individuals. For the sake of brevity, we have identified allies as a client, instance of a client through your browser. And we have identified Bob as our server, our web server, probably in the data center, probably as a shared space on some hosting such as GoDaddy, probably a independent server hosted at your place. So when content travels over the network, we are supposed to consider this OSI layers with reference to the data transmission. So we are aware there are 7 layers. If you start from the bottom, you have a physical layer wherein you have to consider your transmission cable, your UTP, or probably your fiber optic, which connects to your hub. Then you have a data link layer, you have a network layer. The logical layer is your transport layer, where you are clearly communicating. Alice and Bob communicate through the transport layer. We have a session layer wherein, since we know HTTP is a stateless protocol, in order to associate a unique session for each browser of instance of a browser, we associate session layer. You have a presentation layer to ensure that irrespective of the platform being used, irrespective of the operating system being used, there is always a uniformity for the content to travel between the uh, participants of a network through presentation layer. And at the top, you have an application. For example, you have your email client, or probably you also have your FTP client, or you have a web application on which you are logging on to, say, your maps or probably YouTube. So let's just see how the OSI layer attacks take place. So if you consider the physical layer, we already know your wire carries electric signals. Ultimately, your data is converted into signals. We are aware that the content travels as in form of binary signals, machine code. That's how we associate or attribute things. So your physical content is converted to electric signals from those binary data, and there is always a possibility that you can attach some reader, you can attach a sniffer for the network you wish to actually monitor. So on physical layer, an example attack is a sniffing attack. What is sniffing? Sniffing is just trying to see what's happening around, right? Then at the data link layer, you have your network card attached. The content comes out of the machine through the NIC, network interface card. It goes into the machine through the NIC. So at the data link layer, you always have an opportunity to look at attacks like spoofing. You try to be someone who you aren't. So if I am able to successfully represent myself, Eve is able to successfully associate herself as a legitimate client, then I say I have been able to, as an attacker, used a word called adversary. So as an adversary, I have been successful in using a spoofing attack to attack either the client or the server. You have to remember, in the simplistic term, we have identified a confidential communication between a client and a server, where we call client as allies. So you can have hundreds, thousands, hundreds of thousands, or probably millions of attributes, millions of users who are actually attached to a single web server. For the sake of brevity, we have a single web server, and therefore we have to see that the data link layer associates a spoofing attack in form of a MAC spoofing, probably a MAC flooding, or a VLAN spoofing attack, or a VLAN hopping attack through your network interface card. Remember this. Now, when we consider the network layer, you have something called an internet protocol, right? That network layer always lets the content travel as a packet of some fixed size. So the network layer always is susceptible to an attack, a very frequent or prevalent attack called man in the middle attack. We usually know it by a fancy name called MITM. So within the MITM, you could use something called a ping attack to create a denial of service at the end of Bob. Remember, Bob's your server. There can be hundreds, thousands, hundreds of thousands, or millions of aliases looking for service with Bob. And in very simplistic terms, you already know a lot of times when you are trying to log into your server, log into Bob, it asks you something. Remember, I am not a robot. You have to prove, as a client, you have to prove that you are human, right? Why you need to prove that? Because automated robots, automated bots can actually bring down a server with ease. And therefore, whenever there is an unusual traffic coming out of your network, it becomes very important that we understand that and associate this man in the middle attacks. You allies poses as a legitimate, sorry, Eve poses as a legitimate participant called allies, and is able to perform a man in the middle. So inserting something towards Bob without information, knowledge, or consent of allies. Transport layer. So at the transport layer, you have something called recon. What is a recon? Remember, there are two types of attacks, passive and active. An active attack can only happen when an adversary already has some information about the target. Who is a target? A target is either a client or a server, number of clients and a server. So in that sense, Eve as an adversary is an advanced individual. She would always want a background information that can be used to attack the participants of the network. So then you have something called a recon or a TCP session hijack. Remember, at the transport layer, Alice and Bob actually can identify each other. Remember the TCP/IP protocol suite? TCP gives an exact communication at the transport layer between a client and a server. So someone could just misuse that and perform a TCP session hijack. So Eve actually participates to attack Bob used by hijacking the session from allies. Then you also have a synchronization SYN flood attack. We remember there is a message called SYN, SYN, if you remember your transport layer. There is a synchronization that happens between a client and a server. And it is because of this synchronization that stateful information comes up. So in that sense, session side hijacking or probably a SYN flood attack are always possible at the transport layer. Then you have a session layer. Remember, HTTP is a stateless protocol. Web 1.0 was stateless. As a client, Alice requests 10 times. Never out of those 10 times Bob ever remembers Alice after sending her the requested data. So in some sense, Alice would be disgruntled. Alice would believe that server doesn't know her. Right? There can be numerable instances of Alice because there are multiple clients logged on to one web application, one web server at a time. So in that sense, remember that a unique session ID is created for each client and one server. So one server probably handles 1,000, 100, 10,000, 100,000, hundreds of thousands, or probably millions of users, millions of clients at a time. So millions of LICs have logged on. So in that sense, someone could just hijack Alice's session, say she was logged on to a email client, a Google Mail client, and if Eve is able to actually rob off her session and appear to be Alice, then we say it's a session hijack. You can use malicious applications to do that. Session side jackings are also possible. So just remember, we are only considering this active attributes on the network because information security is just not information security. It's also a part of network security because information travels over an unsecure network. I emphasized on a few things if you remember them. I emphasized that network is important when communication happens. And as a brief course, as a course in probably your second year, you already are aware about how network communication happens and how content travels as packets, content travels as an application, with a session ID towards the client, as packets on the network, which are converted into frames. Frames are converted into electric signals and they travel over those bundle of wires across the globe. Now, as I said, uh, there may be different operating systems, there may be different platforms that the client and servers may be deploying and using for communication. So a presentation layer handles them. There is a seamless travel of data which is handled by the presentation layer. So phishing attacks, right? You deploy a social engineering attack at the presentation layer, and at the application level, you use large number of exploitation tools to attack them. So you have to remember that these attacks are all possible while confidential transactions going on. Eve would surely try to deploy one off or one and more attacks at various layers. But remember, reconnaissance happens. Attacker always identifies the avenues to surely attack, to identify the attack and move forth. So if you come here now, let's just see what are different security services, mechanisms, and attacks. So let me just type that. Let's just see what are the security services and what are the security mechanisms. So in that sense, whenever we need to deploy security, right, whenever we wish to associate security with reference to information, we'll always remember that security mechanisms are various ways and means to enable or to ensure security. So one of them that I discussed is cryptography. So cryptography or encryption or encipherment is a mechanism that is used to ensure that a transaction between two parties, that is Alice and Bob, remains confidential. And for that, the text, which is usually known as plain text, remember the first session, the plain text is converted into a ciphertext using some mathematical functionality. And that functionality which is embedded within is called algorithm. So we have different ways that we are going to discuss in the coming classes. So encryption is one of the security mechanism. Then you have something called access control. What does an access control mean? Access control means you provide some access rights depending on the user, depending on how the rights are associated. So people with more responsibilities will be assigned more rights. People with lower responsibilities will be assigned less privileges. So in a way, it's a kind of a privilege mechanism. Access rights, an administrator would always have a super user and SU rights. However, when people will go below specific levels, access control will differ. Then you have a security mechanism which is called notarization. If you remember this in simple terms, whenever you take an oath somewhere on paper, you pledge that what you state is correct. So then you go to a lawyer who also is a government notified notary. He will state that what is stated in this document is correct. That's notarization. So even here, you have to remember, if there's some server, doesn't mean server is always going to be legitimate. It's always going to be a genuine individual. The way Alice could become Eve, or probably Eve could become Alice, right? A genuine user might just hop towards an attacker, right? A genuine user might just become an attacker because the genuine user finds that there is a lot of privilege in terms of monetary rights that she is going to enjoy. So in that sense, even servers are sometimes probably turning from the white to the black, going from white to black, moving. So in that sense, a certificating authority or probably a notarized individual on the internet certifies that, notarizes that this server, this provider is genuine. So there is a notarization that happens. There is also a mechanism which is called integrity that is very important. A server posts some content. You buy that content. You will say, for example, you are buying a movie. You are buying an operating system. You are buying an application software. So gone are the days where these things were available through diskettes. Now people pay and they download. So when you download an operating system, say a licensed version of MS Office from Microsoft, then when you pay, you'll be able to gain access to its application, to its executable code, its setup. So when you download it, integrity ensures that the software that you downloaded from the Microsoft is exact copy of what was hosted there. What does this mean? This means someone in the middle, an attacker, an adversary has not been able to modify that, right? And to know that, to identify that whitelisting, we already have something called, what do we have? We have a mechanism or a way which is already specified. If you see here, a message digest, a cryptographic hash. So remember, this is very important. So data integrity is a mechanism that ensures whatever arrives towards the client is legitimate and is exactly what was sent by the server. Then there is something called authentication exchange, which is also a security mechanism. So what is an authentication exchange? Authentication exchange is a mechanism wherein a server verifies the client. And remember, a client as well can verify the server. So it's a two-way street. See, remember, in the principles of information security, there is nothing which is genuine throughout. A client who appears genuine today could be an adversary tomorrow. Similarly, a server appears genuine, a server appears normal today. Its functionality is normal. But we cannot assume that this server is always going to remain that. There is always a fine line between this. There is something called white and black. So a white is a defender, a black is an attacker. Probably a blue is a defender, red is an attacker. So there always is a transition between these colors, right? For a particular period of time, a, a member of a blue team might create an attack as a strategy to defend itself. So in that sense, client and server both should be able to verify, authenticate themselves. So there is an authentication exchange, which is also a part of the security mechanism. Additionally, we all know the content, the machine code is either 0, 1, 0 or 1. So the content travels in binary. That machine code, we can always employ adding the bits, either preceding or succeeding, because whenever there is an accident, I would stuff bits to see that the content is protected, remains protected, so that there is no issue while the content travels. There is also an option of digital signature which is available for some time. So in that sense, we have to remember that the digital signatures are ways and means to identify one individual as genuine or malicious. What does it mean? If I am participating in some tendering process, to associate myself as a legal entity to participate, I'll always take a digital signature. Web as such, I mean, when you create a file, there can be n number of copies of it. But when you want to protect that file, since you own it, since it's your intellectual property, then in that sense, a digital signature, a document signed by the owner of that object, is through a process which is called digital signature. So remember that encryption, access control, notarization, data integrity, authentication exchange, bit stuffing, and digital signature. These are some examples of security mechanisms. And an adversary would always identify, associate, and find chances to be able to attack one or more of these security mechanisms. If I am encrypting the data, Eve would identify ways and means to be able to break the encryption without having access to the key. So important to remember, mechanisms are ways for protection. An adversary would always find use cases so that they are able to attack these security mechanisms. So let's just come back to our syllabus. Just see mechanisms and attacks. So let's just see what are attacks. So the types of attacks are active and passive. Let's just briefly go through them. So when we look at attack types, there are two specific categories. One type of attack is called an active attack, and the another category is known as a passive attack. So what does this actually mean? Right, let me just go to passive attack and then we'll briefly discuss what they are. So there are a lot number of attacks that we see here. Let me show you through a diagram. Fine, that would be better. Okay. Right, so if you see here, I mean, let the names differ. It doesn't make a big difference. Alice and Bob. Alice is always a client, Bob is a server, and Eve is an attacker, right? So we follow that terminology throughout so that we are able to ensure what happens around while we talk about security. So let's just see, say active. So let me just come here and just show them. Okay. So now let's just see. Okay. These are the two categories of attacks, active and passive. Now, what is the difference? The difference is whenever an attacker wants to attack its target, attacker actually needs to identify, associate, understand who he wishes to, whether he wishes to attack a client or an attacker, an adversary wants to attack a server. So to do that, he needs to do some reconnaissance. We saw that while we were discussing the OSI layers. So in order to attack a client or a server, when I attack someone without being an active participant, I am a passive attacker. So let's just go to what a passive attack is. Passive attack is a security attack in which the attacker is in indirect contact with the target system, or network, and he passively monitors the system. His job is to do a reconnaissance. But remember, when you want to actively attack your target, you need to know what's happening, how your client works, how the server responds. Only then you would be able to attack somebody. So you try to intercept the messages, you try to do an eavesdrop on the data transmission without making a change. You are just trying to look at what's happening around. You are trying to eavesdrop around. So that's how a passive attack is. What are the types of passive attacks? When you just release some message content after reading it beforehand, using a tool like Wireshark, if you do a network data traffic analysis, if you are able to do a network map, or just remember this, you are trying to just sniff, you attach one device to the cables, the main cables of the target network, and you just see what's moving around. This is very important because an attacker, an adversary would only be able to attack his target when he has enough information about the target. So passive net attacks actually supplement the active attacks. So when we go to an active attack, let's see. An active attack is an attack where attacker directly communicates with the target system. So here now, whatever information is available, using that information, if I am able to execute an attack like this, a hijacking, a man in the middle attack, spoofing, phishing, or use an exploit to attack the system, then I am actually performing, I am doing, and I'm part of an active attack. So now remember, I gave the examples of certain active attacks. Here, what does an attacker want to do? He wants to modify. He would like to modify, disrupt the system or the network functioning by injecting something which is not good. In short, we are trying to attack a genuine server or a client using injection methodology or executing unauthorized commands. I am not a legitimate user. If as an attacker identifies how it would like to attack the target based on the passive information that Eve got while she performed a reconnaissance. So what can happen? It can just make the server go non-integrous. It will ensure that the availability of a system or network is no more. So a denial of service by a server is again not serving the client, and hence I believe there is a lot of issue that's going to happen. So in a way, we are compromising the data integrity and we are reducing the availability of system resources, leading to a significant damage, or a very important aspect, leading to a financial loss of the target organization. And this could actually affect the safety, security, and privacy of the clients, one or more clients. For us, Allies is an example of those clients. Let's go back to the syllabus. So we have ways and means to encrypt the content. A plain text is converted into a ciphertext. Something which is understandable is converted into a jumbled text, and hence it's called cryptography. So if you remember security mechanisms, the first one was encipherment or cryptography, right? So what's a cryptography? We just want to discuss what is cryptography, right? Public and private cryptography can come later. So let's just check the definition of cryptography. Cryptography is a process of hiding or coding information so that only a person for whom the message was intended can read it. It is exactly similar to someone locking his home. Why similar? To lock a house, you need a lock and a key. So you always lock your house. You use a lock wherein there is a key. So lock is an algorithm. The key is required to either lock the home or unlock the home, lock or unlock the door. So what is more important? I use a 7-lever lock. So that's a good lock. I depend on the quality. Similarly, to lock some plain text, I need an algorithm. But within the algorithm, a user would always require a key. So remember, some content which is called plain text, which I already have discussed in the first class, can be hidden, encoded, enciphered using a key. So the art of cryptography has been prevalent since thousands of years. Remember that. And now we are actively using that in financial transactions, computer passwords. Also, e-commerce is very prevalent. So in that sense, it is very important for us to remember this, that we can use cryptography, we can use encryption to protect our consumers' private and sensitive information. What's the private and sensitive information? First name, last name, mobile number, email, password, gender, preferences, all of this information is a private information. Additionally, it is a sensitive information. So encryption can be used as a mechanism, one of the mechanism to secure this private and sensitive information. If encryption is used, an attacker would always want to use a methodology to decrypt. Message digest and hashing. So let me just give you a definition of what things are with reference to the same, and then we can wind up this topic. So let me just say cryptographic. A cryptographic hash is a mathematical function used in encryption. The beauty of a cryptographic hash is whatever be the size of the file, say it's a 1 MB file. Let's make it a bit bigger. It's a 100 MB file. Let's make it a bit more in size. It's a 1 GB file. Or probably your Windows, which is probably 7 gigabytes in size, the setup of your Windows operating system, right? Probably your Linux operating system setup is probably a 4 to 5 gigabytes in size. So if I wish to create a signature of this file, this could just be 100 bits. This could just be a 128 bytes. This could just be a 256 bytes. So that becomes a signature. It's a one-way function. A hash function takes input a variable file, any size file, and it will always return an output of some fixed length. And we call that as a cryptographic hash function. Please remember, a cryptographic hash is usually a mathematical function which takes a variable size input and it always gives you a fixed size out. So this is typically a way to create a fixed size signature for a particular file. So I said it a while, some time back. I said that if Microsoft Windows is downloaded and I wish to know whether any change has happened while it was downloaded, I can check it with a cryptographic hash. If we go to the syllabus, there is something which is called a message digest. This is a kind of a cryptographic hash which gives you a 128 byte content. So MD5 sum is a cryptographic hash. Similarly, what you see here, secure hash algorithm. So these two are examples of encryption via a mathematical one-way function, which is called a cryptographic hash. So as of today, I believe we have discussed a lot of things wherein we are able to actually look at first unit of information security, your first topic of cybersecurity. And I would surely want to move on to the second topic and we'll discuss that in detail so that as a programmer, you are actually able to ensure you provide the level of security that your client desires. Remember, security is not an add-on. Your programs that you are developing, your projects that you are developing, an attribute, a pillar should be your program should be secure by design. So while you consider security, remember that security is a process. It's not an end product. So see you soon in the next class. Bye-bye.